Hi everyone. Um, so previously we looked at the cosine rule. So now we're going to look um, something within triangles. Yes, I know. I spent an inordinate amount of time creating that, but we're going to look at something called the sine rule. So there's some kind of connection between sides and what I will call, and many other people will call, their corresponding angles. So that is, apologies about a small triangle here, but I'm just going to use a convention of using the kind of larger uppercase letters to indicate the vertices or angles within, and lowercase to represent the corresponding sides. So if I pick an angle big A and its corresponding length small a, we can come up with some sort of relationship, some sort of connection. And I'm just going to initially put it as the side over the sine of the angle. I could have actually put it the other way about. It doesn't matter. I'm now just going to move through all sides and corresponding angles and come up with some. So B, small b with angle B, and I'm going to write that as small b over the sine of the angle B. And guess what? Thirdly, we're going to have small c over the sine of angle C. That's not angle C as in off the coast of Wales. I just thought of that. So, this is sometimes known as the sine rule. You can see we're taking the sines of all the angles. So it looks like we've got ratios here. Previously, when we were looking for the area of a triangle or the cosine rule, we only ever had 4 things involved. One you were looking for and 3 that you had. Here it looks like we've got 6. So I think, well, I don't think, I know, we're just going to reduce this down to basically 4 inputs. It doesn't matter which 4 we take, but just to simplify it, I'm just going to use these 2 parts. Just remember, small a, big A, small b, big B, there are only labels. Okay, just let's go for it. Here, since I've started this off referring to this as a sine rule, that's what we're going to be using. So it looks like there's 2 lengths involved. I've got 20 m. I'm going to assume that's 20 meters. I've got a side length of x. Right, so I've got a side here, and I've got 2 angles. 2 angles, 2 sides suggests that it is the sine rule. I'll give you a method later to actually clarify that. So what we're looking for here, so it fits in the formula, I'll refer to that as A, and the corresponding angle is big A. So come across from the side A without hitting it 2 other sides, and that's angle A. Right, so the other 2, so the 20 meters at B and its corresponding angle at big B is 45. So we'll get everything labelled here. Let's bring on our general rule here. So A over sine A equals B over sine B. So in position A, I was saying solve for x, so we could put an x in there. and in B we can put a 20 up there, sine A, so it needs to be sine 30, not just 30, and sine B and sine 45. That's what we need to put in there. Aim in a game is to get x on its own. Forget about the other side. It's this side you're interested in. X is being divided by this thing, sine 30. Sine of 30 is just a number, right? So something divided by something. Well, this something down here, because it's dividing it, I want to take it up to multiply. I can either put it at the front of that fraction or to the rear of that fraction. It doesn't matter. I put it behind for some reason. Right, now it's calculator time. So it's going to be 20 divide, because that's a fraction, sine 45, then times sine 30. But the thing is, you need to watch your calculator. 20 is fine, divide's fine, that's fraction, sine. But when you hit the 45, your calculator should open up a bracket. If it doesn't, then you need to. But the important thing is you need to close the bracket after the 45. So that's why I'm inserting them here. So these brackets are important. If it was just 20 over sine 45, you get away with it. But because we're multiplying it here, we need to make sure we close the bracket after the 45. If we didn't, then it would drag everything downstairs. Believe me, it would. Okay, get your calculator. So 20 over sine 45 times sine 30. Some of your calculators, what's that going to be? 20 times half 10. 1 over root 2. That might give you something like, I don't know, 10 root 2 or something like that. I think it would. No, no, not 10 root 2. No, 5 root 2, because sine 30 is a half. Right. It might say 5 root 2 in your calculator, so you need to change the mode. Well, you don't need to. 5 root 2 is an acceptable answer, but we're just going to go for decimals here, because sometimes you might be science students, engineering students, not necessarily strictly mathematical students. So we're going to go for 5 root 2, 5 times whatever that is. 5 times 1.414 is about approximately 7.07. Oh no, so that's 14.14, sorry. Tommy Shaw. Ah, that's right, 10 root 2. Aye, so 14.14. You might have other stuff after the 1 4. You might have 2 1 3, or you could put 14.1. Doesn't matter, as long as you could put in the units of measure here. Right, hopefully that was kind of straightforward enough without me confusing you too much. So let's go for another one. Let's calculate the length of side x. Right, so it's definitely sine rule because there's two sides involved. One we're looking for, one we have, and there's two angles involved. So 2 and 2 means it's sine rule. Okay. If you think you have to label the sides and corresponding angles, then do so. That's what we're looking for. A corresponding angle up there. We don't have, but I'm sure we can find it. Other side we have corresponding angle is B. We have, that's fine. Let's tie these up. So it looks like we don't have the angle A that we need. We definitely need that. But the thing is, with your knowledge of triangles and their internal angles, you should know that they all add up to give you 180 degrees. So angle A, angle B, and angle C is 180 degrees. So we've already got 35 and 70 in there. So if we take them away from 180, we should get a required angle. So I've just did 180 take away the 70, then I've taken away the 35 to hopefully give me 75. Just check that in your calculator, just to make sure I haven't made a mistake. Right, I need that angle. So I'm just going to put it in there, and I've got rid of that angle C, because it just clutters up the place. Just score it out. I can now go back to my sine rule. I'm looking for a side, so that's why I've got small a and small b up the top. You're looking for sides, put the sides up the top. Numbers in position. Okay. We need to isolate x here, so get rid of that sine 75. That's effectively a number. So bring it up to multiply because it's dividing there. Either put it at the front or put it at the back. It's up to you. I'll put it at the back. As per the last one, just remember that the angles that you're taking the sine of, we need to bracket them up. Then we put it in the calculator. I don't think this is going to be a nice answer here, but you might get 12.3. I don't know. Maybe add more decimal places there. I think I'm going to go for 12.3 because I didn't specify the number of decimal places. Right, so it looks like here we can now find a side with a sine rule. Right, let's move on. Yet again, it is a sine rule because there's two sides involved and there's two angles involved. So two sides, two angles means sine rule. And we're just tying up corresponding sides and angles. You might want to use the word opposite. It's up to yourself. But this time, the reason I'm writing it like this is because I'm looking for an angle. So instead of A over sine A, I put sine A over A because this is what I want to find. It just makes the algebra easier because it just means I need to just get rid of small a. Okay, that's all it means here. So let's put things in position. But this time I don't have x in it, so it's sine x, but I can get rid of that 10. I can bring that up to multiply either front or back. That doesn't matter. So I'll put it in there. But this time I can't just put that in my calculator. Well, I could, but I get an answer, then I'd probably need to round it. So to get rid of sine, to leave x on its own, I need to get the opposite of sine, which is the inverse sine. And sometimes you call it sine with a -1 of all that stuff. So here, get your calculator, inverse sine. As soon as you type that, shift sine, -1, it'll give you a bracket here. Then type in all this, but see that 69, can you make sure that you bracket that? So inverse sine, sine 69 close bracket, divide by 11 times 10, close a bracket there. You might get away with it, but just get into the habit of closing it and see what your calculator gives you. 58.1, 58.07, might have more decimals. Doesn't really matter. If it doesn't give you a whole number, exactly 58, just get in the habit of putting decimals here. And I say quite a lot, because this is in video format, you can pause it, rewind, and then just have a little look at that again, just so you can get to grips with what's going on here. Okay, we're reaching the finale here. The whole purpose of these little videos is not to give you an exercise that you go through one at a time. You'll get that elsewhere. The thing is, whether it's sine rule or cosine rule, there's 4 things involved. 3 that you're given, 1 of which you're looking for. So I'm going to look at this diagrammatically, give you pictures. So here, 1, 2, 3, I've got 3 sides which I actually know the values of, and a little cross here means I'm looking for something which looks like an angle. But the important thing is here, I have got 3 sides. Whenever you've got 3 sides, that means it's a cosine rule. And why is it for angle? Because I don't know what the angle is. Next diagram. Again, I've got 1, 2, 3 sides involved. Doesn't matter that I don't know the value of that, I'm looking for it. But 3 sides are involved and an angle's involved. Only one angle, just like that there. So that, again, that means it's a cosine rule, but I'm looking for X marks the spot. So this is cosine rule for side. That's what you need to remember. Okay, cosine rule always involves 3 sides and only one angle, whether you have it or not. See anything else? That's the sine rule, which starts with either A over sine A or sine A over A, depending upon whether you're looking for the angle or the side. So just rewind back to the start, and you can also have a look at the cosine rule video, and just to see this should apply to both of them. So I think I'm going to wrap it up here, folks. And oh no, I'm not. I'm going to give you a little test here. So the little test involves, what are we on? This it means cosine rule for angle, cosine rule for side, sine rule for angle, sine rule for side. See, that's what happens when you don't write your script down. Right, so I'm going to give you 4 triangles here with certain information, and I want you to put down which one of these you think it is. Okay? There you go. I don't want you to solve these, but you can later on. So have a look at them. Right, so I'm going to be quiet for a minute or so, and then I'll let you have a wee think of this, or a think about it. I know some of you are conscientious, and you're saying, wait, I've not finished yet. But I know some of you are just saying, look, please go on with it and show us the answers. So we'll deal with these one at a time. Um, let's let's deal with this one here. So what do we have here? I've always got 3 pieces of information, so got 1, 2, 3, but I've got two sides and two angles. So two sides, two angles. Maybe that will suggest to you sine rule. Two sides, two angles is sine rule. And what you're looking for an angular side, well, what's that you're looking for a side here? So sine rule for side. Next one, what have we got? Right, okay. One angle. We got 1, 2, 3. 1, 2, 3. Three sides are involved. Three sides involved in only one angle. What does that tell you, maybe? Three sides, one angle. Hopefully that tells you that's a cosine rule. Cosine rule for what? Well, cosine rule for side, because x marks the spot on a length. Okay, right. Let's move downstairs. Okay, what have we got here? Right, here, 1, 2, we have all three sides, and one angle again involved that we're looking for at this time. So 1, 2, 3 sides involved, again, suggests the cosine rule. Okay, so, but the thing is, what is it? Cosine rule for what? What's cosine rule for angle, hopefully? That's why I put CRA. Okay. Right. Finally, this one, get it away there. Let's go up here. What have we got this time? I've got two angles involved. I'm looking for one. Two angles involved. I've only got two sides. So that's like the first one. Okay. Two sides, two angles, two sides, two angles. So this for me is a sine rule. Sine rule for what? Well, I would think sine rule for, well, x is marking the spot of an angle. So that's sine rule for angle. And I've just put them all down. So if you have some kind of exercise, assessment, they don't always say, oh, can you use the sine rule to find the angle? Right? They will just give you something like this here, naked, like that there, and you'll have to figure it out yourself. You'll probably have a formula sheet. So think about what you need. Two sides, two angles, sine rule. All three sides involved, only one angle, cosine rule. All three sides involved, one angle, cosine rule. Two sides, two angles, sine rule. So, but in general, for the sine rule, whether it's angle or side length, it can just be written like that there. And that's what we had to start with there, folks. So it's just ratios of sides to sine of angles and vice versa. Okay, so I'm going to finish this one here. Hopefully that wasn't too long. Oh, not too bad. Just under 25.5 minutes. That's okay. Right. Well, good morning, good evening, good afternoon, good luck. Bye.